In this video, we are going to look at motion in a horizontal plane. Let's have a look at this picture here showing a person pulling the box to the right. Since we are told that this is a rough surface, or maybe let me make this surface rough like this. Let's assume the surface is rough, meaning that if the surface is rough, we have a friction force that takes place. Now, let's draw a free body diagram. We have a normal force that is pointing upwards like this. Some may even prefer to write it as Fn. We have the force of gravity pointing down like that. Then some may even write it as Fg. We also have the force applied. The force applied is the force that this person applied to the box. We can also write it as Fa. We also have a frictional force that can be written as Fk, like that. Now, the normal force and the gravitational force are equal, and the direction of this box, or the direction of the motion of this box, is going to the right, meaning that this box is not going up and down, and as such, the normal force and the gravitational force must be balanced or must be equal, indicating that the box is not going up or down. The frictional force and the applied force must not be equal for this motion to occur. If frictional force is equal to the applied force, we are going to have a problem in moving this box, because if the force that we apply is the same as the frictional force, then the box can't move forward. Now, I want us to take note of these two forces before we proceed and checking the equation out. Let me write M here. However, when you draw free body diagram, you don't need to write this M. I just include it to show that we have a mass of this box that we can even consider. Now, I want us to look at this table. By the way, you don't need to memorize this table. It's always provided. I want us to look at these two forces, F net and also the kinetic frictional force. There is a relationship between kinetic frictional force and the normal force. This N is for the normal force, the same Fn that you can see. So you can even write Fn as capital letter N like this one. So that's the relationship that we have between frictional force and the normal force. So when we talk about F net we are just referring to all forces that are of the direction of the movement. So in this case, our F net, which are the force that are of the direction of the movement, it's Fa and also Fk, because that's the horizontal forces. Meaning that instead of writing F net, we can write Fa minus Fk. From there, because that's the forces that are on the direction of the movement of the motion of the box. However, if the surface was smooth, not rough like this means frictional force was not going to be part of this F net here. But in this case, since we know that the surface is rough, friction play part. Now, this simply means that we can rewrite this formula in this manner, and we say mu k multiplied by n, and this will be equals to ma. Look what I did. I replace Fk, or the frictional force or kinetic frictional force, by this equation here. However, I want you to note that this normal force has a relationship with the frictional force through this equation. I want us to look at an example. Calculate the acceleration of a 12 kilogram or kg box pulled in a rough horizontal surface with applied force of 50 Newton. The coefficient of kinetic friction between the box and the surface is 0.2. Now, we know that the acceleration from this equation, you can just divide here by m, you divide here by m, you should be fine. Now, F applied minus mu k multiplied by n, all this divided by m. That's the formula one can use. However, we have the relationship between the normal force and the frictional force. What is the relationship? Is given here to say frictional force is equals to mu multiplied by normal force. However, we know that the normal force is equals to Fg, and Fg is equals to mg, or mass multiplied by gravitational. Why normal force is equals to Fg? Ladies and gents, this capital letter N is the same as this Fn, or normal force. In other words, N stands for normal force, Fg stands for gravitational force, and we know that gravitational force is mass multiplied by force of gravity. Why normal force is equals to Fg? It is because this box is going horizontally, it's not going up and down. In other words, the force that is the normal force is equals to the gravitational force to hold it in a position whereby it will just move in the horizontal direction. In other words, this force must be balanced. The normal force and the gravitational force must be balanced. Balance, I mean they must be equal so that the box can go up, either up or down. So now, having said that, we can just replace this normal force with mg. Why? Because we know that they're equal, so we can just come here and replace number of mole with mg and write Fa like that, minus mu mg all divided by m. From there, it's just a matter of substituting. We know that F applied is 50 Newton, minus we know that the mu is going to be 0.2 multiplied by 12 multiplied by 9.8 divided by 12. So from there, we press a calculator and find the answer being 2.2 meter per second squared.